Hi everyone, this is Lab 10.2, determining the molar mass of an unknown solid acid through titration. So what I have in this bottle, I'm purposefully holding the label away from the screen, is a solid acid, okay, an acid that has yet to be dissolved in water, making an aqueous solution. And it's going to be our goal to determine the molar mass of this solid acid through our experiment today. So our first step is I'm going to measure out a known mass of this unknown acid, and to do that I'm going to walk us over to the balance. Now you may notice that I'm not carrying the large bottle of acid with me because I've already put a little bit into this weigh boat. So it's a little bit easier to pour from the weigh boat as opposed to pouring from the large bottle. So with that being said, I'm just going to be weighing in this capacity. Now, I know you can't see the values on the balance all that well, but I'll say out loud what the mass is so you can jot down that value. Let me zero our balance so we can get a little bit more accurate of a mass. We're going to be using a rather small mass, so it's important to get as accurate of a value as possible. Okay, and this balance takes a while to zero, so we just have to be patient. Still waiting for it to be zeroed. Okay, there we go. Okay, so we are at 0.4256 grams. 0.4256 grams. Okay, so I'm going to bring us back over to our workstation. Pop you down here. Okay, so our next step is I'm going to take our solid acid and transfer it into our Erlenmeyer flask to ensure that all of the acid has been transferred into the flask. I'm going to spray the flask with deionized water and have the runoff run into the flask. And to ensure that our entire acid is dissolved, I'm just going to add some more deionized water. This is not the most effective way to do it, but I'm already halfway done. The more effective way would be to unscrew the cap of the deionized water and pour directly. So once again, my goal here is to dissolve all of our solid acid so that we have an aqueous solution of our unknown acid. Just added a little bit of extra deionized. I'm going to swirl it around here. Make sure it is all dissolved. Now, similar to our last titration, I'm going to need an indicator that's going to tell me when this solution changes from an acidic solution to a basic solution. And the indicator that I'm going to be using, similar to last time, is phenolphthalein. Okay. That's phenolphthalein in there. Now, I have already filled up our burette with 0.1 molar sodium hydroxide. So once again, we have sodium hydroxide. It's 0.1 molar. It's already in this burette. And I can read the initial volume now. The initial volume is 0.30 milliliters. 0.30 milliliters. Okay. And now it is time to titrate. So, general idea of where the end point for this titration will be. So I'm going to be a little bit reckless with the titration in the beginning, and then we'll slow down once we get closer to that end point. So I'm just going to let it rip right now. Now what you'll notice is there's already pink forming in solution. It's gone now, but as I open this up, we will immediately start to see the pink. Shake it up. That pink's lasting a while now. So I'm going to start getting a little cautious. I'm going to start getting cautious. Okay? Don't want to overshoot. This is a little bit earlier than I anticipated. Having to be careful. I did not expect that to be careful this early. It's a little reckless. Ooh, okay. That was a little scary. That one didn't seem to be going away all that quick. Now it's time to really go at it a bit slower. And some drops there. Now, the reason why you see this pink lasting for a longer time, ladies and gentlemen, is there's less acid in the solution as time goes on. So the hydroxide ions don't react as quickly because there's less hydrogen ions for them to react with as time goes on during this titration. Wow. Perfect titration pink. Yes, you cannot see that. Now, some of you may be saying, that looks clear to me, Mr. Rice. Want me a white piece of paper back there? You can see it is pink. Maybe you can see. Now, I will add one drop to show you what happens, but I'm going to take our volume reading now. We are at 17.60. 17.60 milliliters. We will add one drop to see what kind of impact that has on our solution, but it is difficult to tell in the video. This is very, very perfect in terms of our titration pink. See what one drop does. That's one additional drop. And look at that. So you can see one additional drop turned us significantly more pink. So that was where we needed to be. That was a perfect volume. And it's a good thing we recorded that volume measurement. Okay, so that took, quick math here, 17.3 milliliters of 0.1 molar sodium hydroxide. We now have sufficient data to solve for the molar mass of the unknown acid. Take a look at your lab document. Follow the questions in order so you can determine the molar mass of the unknown acid. Once you have your molar mass, reach out to me in the chat on Zoom, and I can tell you how you have done.